Hey everyone, welcome back. Today we're exploring the sun and the moon. Get ready for the top 10 fascinating facts about these celestial wonders. The sun is a star, the closest one to Earth. It sits at the center of our solar system, a constant presence in our sky. It's a colossal ball of burning gases, a gigantic nuclear reactor. The sun's surface, known as the photosphere, is a seething mass of energy. Imagine a sphere so massive it could hold over 1,000,000 Earths. This immense size gives the sun its powerful gravitational pull, anchoring the planets in their orbits. The sun's energy drives everything from weather patterns to planetary orbits. Its influence extends far beyond just providing light and warmth. Composed mainly of hydrogen and helium, the sun is a chemical powerhouse. These elements are the building blocks of the universe. The sun's core fuses hydrogen into helium, releasing immense energy. This fusion process occurs under extreme temperatures and pressures. This process, nuclear fusion, powers the sun. It's the same process that powers hydrogen bombs, but on a much larger and more controlled scale. Every second, the sun converts millions of tons of matter into energy. This energy radiates outwards, reaching Earth and other planets. Despite being an average-sized star, the sun is crucial to our solar system. Its energy sustains life on Earth and influences the entire solar system's dynamics. Understanding it helps unravel the mysteries of the universe. By studying the sun, scientists gain insights into the life cycles of stars and the workings of the cosmos. The sun also produces solar flares and coronal mass ejections, which can impact space weather and even disrupt satellite communications on Earth. These solar activities can create beautiful auroras, lighting up the polar skies with stunning displays of color. The sun emits a stream of charged particles known as the solar wind, which shapes the heliosphere, a vast bubble that envelops our solar system. The sun is currently in the middle of its life cycle, a stable phase known as the main sequence. It has been shining for about 4.6 billion years and will continue to do so for another 5 billion years. Eventually, the sun will expand into a red giant, engulfing the inner planets, including Earth, before shedding its outer layers and leaving behind a white dwarf. This white dwarf will slowly cool and fade over billions of years, marking the end of the sun's life cycle. The sun's importance to our existence cannot be overstated. It is the source of all energy on Earth, driving photosynthesis in plants and providing the warmth necessary for life. As we continue to explore the sun, we unlock more secrets about our own planet and the universe beyond. The sun remains a focal point of astronomical research and a symbol of the enduring power of nature. Our understanding of the sun will continue to evolve, but one thing is certain: it will always be our star, the heart of our solar system, and a beacon of light in the vastness of space. Now let's shift our gaze to the moon. It's Earth's only natural satellite, reflecting sunlight to shine. The moon's phases result from its orbit around Earth. From new moon to full moon, its changing face has inspired myths. The moon's gravitational pull creates tides on Earth. It also stabilizes Earth's rotation, preventing drastic wobbles. Without the moon, our planet's climate and seasons would be chaotic. So, the next time you see the moon, remember its vital role. It's not just a celestial spectacle, it's essential to Earth's balance. Prepare to be amazed by the sun's core, a nuclear furnace. Temperatures soar to 27 million degrees Fahrenheit. At these extremes, hydrogen atoms fuse into helium, releasing energy. This nuclear fusion powers the sun. Every second, the sun converts about 600 million tons of hydrogen into helium. This energy radiates outward, taking millions of years to reach the surface. The sun's core is a testament to the universe's power. The moon is an airless desert, a stark reminder of space's harshness. Without an atmosphere, temperatures swing to extremes. Daytime temperatures can reach 253 degrees Fahrenheit. At night, they plummet to minus 243 degrees Fahrenheit. The lack of atmosphere exposes the moon to cosmic rays and impacts. Its surface is pockmarked with craters from countless collisions. The moon's harsh environment highlights Earth's protective atmosphere. Our sun isn't immortal, it has a story, a journey that spans billions of years. It has a finite lifespan. Currently, it's a main sequence star, a phase where it spends the majority of its life. During this time, it fuses hydrogen into helium in its core, producing the light and heat that sustain life on Earth. This process of hydrogen fusion will continue for another 5 billion years, providing a relatively stable environment for our solar system. However, this stability won't last forever. Eventually, the sun will exhaust its hydrogen fuel. As the hydrogen in the core depletes, the core will begin to contract under the force of gravity. This contraction will cause the outer layers to expand dramatically. The sun will swell into a red giant, a phase where it will become hundreds of times larger than its current size. In this red giant phase, the sun's outer layers will engulf the inner planets, including Mercury and Venus. There's a possibility that Earth, too, will be consumed by the expanding sun. If Earth manages to escape being engulfed, it will still face a grim fate. The intense heat from the red giant sun will scorch our planet, turning it into a lifeless, barren husk. But the story doesn't end there. After the red giant phase, the sun will shed its outer layers, creating a beautiful planetary nebula. The core will remain as a white dwarf, slowly cooling over billions of years. Even in its death, the sun will contribute to the cosmos. The elements released during its final stages will seed the interstellar medium, providing the building blocks for new stars and planets. Thus, the cycle of cosmic creation will continue, with new stars and planetary systems forming from the remnants of the old. The moon is slowly drifting away from Earth. This might sound surprising, but it's a gradual process that has been happening for millions of years. The moon, our closest celestial neighbor, is on a slow but steady journey outward. It's moving at a rate of about 1.5 inches per year. To put that into perspective, that's roughly the same rate at which our fingernails grow. While this might seem insignificant on a yearly basis, over millions of years, it adds up to a considerable distance. This process is driven by the gravitational dance between Earth and the moon. The gravitational forces at play are complex and fascinating, creating a delicate balance that affects both celestial bodies. Tidal bulges on Earth create a gravitational tug on the moon. These bulges are caused by the moon's gravitational pull on our planet, leading to the rise and fall of ocean tides. This interaction is a key factor in the moon's gradual departure. This energy transfer causes the moon to spiral outward. The energy from Earth's rotation is transferred to the moon, pushing it further away. This process is a testament to the intricate mechanics of our solar system. Over billions of years, the moon will appear smaller in the sky. As it moves away, its apparent size from Earth diminishes. Future generations will witness a different night sky with a more distant and smaller moon. Total solar eclipses will become a thing of the past. Currently, the moon is just the right size and distance to cover the sun completely during an eclipse. As it drifts away, this perfect alignment will no longer occur, making total solar eclipses a rare memory. The moon's slow drift reminds us of the dynamic nature of our solar system. Nothing in space is static. Everything is in motion, constantly changing. This gradual shift is a small part of the ever-evolving story of our universe, a reminder of the passage of time and the forces that shape our cosmic neighborhood. Light travels incredibly fast, but how long does it take for sunlight to reach Earth? Light zips through space at about 186,000 miles per second. The average distance between the Sun and Earth is 93 million miles. Sunlight takes about 8.3 minutes to reach us. When you feel the sun's warmth, you're experiencing light from over 8 minutes ago. It's a cosmic time delay that highlights the vast distances in space. The moon experiences its own version of earthquakes, called moonquakes. Moonquakes are caused by gravitational pull, cooling, and meteoroid impacts. There are 4 main types: deep, shallow, thermal, and impact-induced. Deep moonquakes originate hundreds of miles below the surface. Shallow moonquakes occur within about 12 miles of the surface. Moonquakes can last for hours, shaking the lunar surface like a ringing bell. The sun is a dynamic and often volatile star. Solar flares are intense bursts of energy from the sun's surface. They release radiation that can disrupt communications and damage satellites. Powerful flares can trigger geomagnetic storms, causing blackouts. Solar flares also create spectacular auroras near Earth's poles. The sun's explosive temper reminds us of its dynamic nature. The giant impact hypothesis explains the moon's formation. A Mars-sized object collided with early Earth, blasting debris into space. This debris coalesced to form the moon. The hypothesis explains the moon's size, composition, and orbit. Scientists continue to study the moon to refine our understanding of its origins. We've uncovered mind-blowing facts about the sun and the moon. If you found these facts awe-inspiring, like, share and subscribe for more cosmic adventures. Until next time, keep looking up and never stop exploring the wonders of the universe.